All right, this is inquiry lesson 213, estimate solutions with graphs. So basically, we're going to use our graphing calculator as much as we can to find solutions to problems. This is just an introduction. I'll go through with this on a video. If you have your graphing calculator handy at home, you might want to be doing this as we go so you kind of get used to it so that you'll be able to do that in class. But it says graph the equation is 3x plus 4 and y equals 3x minus 2 in the standard viewing window. Describe how the graphs are related. It shows you how to do that right here, and I'll do that with you here. So we want 3x plus 4 and 3x minus 2 in our y equals. It's always good to clear your memory before you start. 3x plus 4 and 3x minus 2. Make sure those are the right equations. They are. Okay. And it says to put them in a standard viewing window. That would be Zoom number 6, standard. And just so you know for future what the standard window is, I'll just press my window button right now, and you'll see that the standard window has x from -10 to 10 with a scale of 1, and same for y. All right, so there's our graph. Now, we have our graphs. We can see that the two lines are parallel. So I'm up to this part 2 right here. The first equation graph is y1, and if we go onto our calculator and press trace, you can see that y1 is highlighted right there, and that's where the cursor is right now. It's on y1. In fact, right when you press trace, you usually put right on the y-intercept, and you can see that by the coordinates of the point here, 0, 4. Okay. Now, if you press your up arrow, what's going to happen is you're going to move to the other equation, and you can see that I moved to the other equation by this. y2 is equal to 3x minus 2. And again, I'm right on the y-intercept. Now, if you press your right and left arrows, you'll move along that line. Notice the x and y values changing as the cursor moves. And you can use this to help solve equations. Like right now, I'm on the equation y equals 3x minus 2. And the values I'm given are these. Y is equal to, or x is equal to 2.7659, and y is equal to 6.297, so on. So what that means is at this spot, 6.29, and there's a bunch more numbers on there, is equal to 3 times the x value, which is 2.76, and so on. Times let's see, 3 times 2.76 minus 2. So I could use this to solve some problems. Like, let's say I wanted to find the value of y for the equation. Let's say I wanted to find the value of y for the equation where x is maybe 4. So I want to know what 3 times 4 minus 2 is. Now, that's not so hard to figure out. I could just do 3 times 4 is 12 minus 2 is 10. But I could also find that on my calculator. I could just trace it. And I want x to equal 4, so I'm just watching the x values change. And I noticed I just passed 4 right there. So it looks like y, according to this, when x is 4, y is about 10. And when my input values, which are my x values, I can actually input those right on the keyboard if I want. So if I want x to be 4, I can just tap 4, press enter, and it goes right to that spot. It says when x is 4, y is 10. Likewise, let's say x is -2. When x is -2, y is -8. So I can find values that way. Now I can't input output values. In other words, I can't find what x is when y is -8. Remember now, the key to all this that I just did is I hit the trace button first to do that. So, and then the up and down arrows change you from equation to equation, and the left and right arrows move you along those equations. So let's say I want to know what x is when y is maybe 2.5 for the equation y equals 3x plus 4, which is one I'm on right now. So what I do is I find 2.5, get as close to that as I can. That's as close as I seem to be able to get there, and it says about -0.42. I can check that -0.42 by entering that into the x. I can enter any input value. It's a little bit off. I can also use my table to find those values. So I can go second graph, go to my table, and my table is full of values for each of those equations, y1 and y2. You just have to remember what y1 and y2 is. My y1 is 3x plus 4. My y2 is 3x minus 2. So let's say I wanted to solve this equation. 17 is equal to 3x plus 4. So I'm looking for an x value that makes my y value equal to 17. So I'm going to go down, and right there my y value is 60, which is pretty close to the right answer. So I can tell right now my x value is just a little bit more than that. And you can get more accurate on your table, and you can find that on your graph also by pressing trace and making sure you're on the right equation. I'm on 3x plus 4. I want y to be 17. So I'm watching my y values increase, and I want them to be 17. There's 16, 16.7, 17.4. So I know it's around 4.25, somewhere in there. I go back to my table, and I want to get close that way. I can go to my table set, and I know x is close to 4. So I can start my table setup, which is second window. I can start that at 4, and I can change my intervals to go up by 0.1. Go back to my table, and now we can see we're getting a little closer to 17. So somewhere between those two values, y is equal to 17. So that's the solution to that equation. Now, if you remember from last year, to me this is the easiest way to find the exact answer. Balance it out, subtract 4 from both sides, and then I get simplify the equation to that equation, divide both sides by 3, and I get x is equal to 13/3, which is the same as 4 1/3. We can see that 4 1/3 is somewhere between those. All right. So in this next problem, you are going to be using the same equation for every part of it. So let's put that equation in. If you decide you want to use your calculator, I think there's a way you could solve all of these problems without. In fact, I know there is. But anyway, this equation is y equals 15 times s, if use x for that, plus 3. Now y stands for the temperature in Celsius, and x stands for the speed of an ant. So the faster an ant can crawl, the warmer the temperature. So It says find the value of t for various values of s. Choose 5 values from 0.5 to 4.0. Record these results in a table. So what you guys are going to do is, on your table, pick some values. So st, now remember on our calculator, s is x and t is y. And remember, s is the speed of the ant in centimeters per second, and T is the temperature in Celsius. So it says use values from 0.5 to 4.0. So and they could be anything. It could be like halves, quarters, whatever you want, but don't go any higher than 4. And I think that's because ants really never run any faster than that. 0.5, 3. 3.5. Now, you could just calculate those out if you want. So T is equal to, I can substitute 0.5 in there for S, so 15 times 0.5 plus 3. And 15 times 0.5, 0.5 is the same as a half. Half of 15 is 7.5 plus 3 is 10.5. So that means the temperature outside is 10.5 in Celsius if the ant is crawling 0.5 meters per second. You could get these a little faster by using your equation and your table. Remember, your table is just full of results that are solutions to the equation. You might want to set your table to start at 0 and go up by halves, depending on what kinds of numbers you pick. If you pick numbers that are in between halves and wholes, then you might set your table set to go up by 0.1. So, and so there's a bunch of values there, so you can use those to fill in your table. All right, and then it says graph the values. So the few values you have, make a graph with those, and this relationship is linear. We know that the coefficient is 15 represents the slope of your line, so you should get a straight line that you can connect when you make your graph. And then you can go ahead and answer these questions, and we'll work on those in class.